The NASA Perseverance rover mission is one of humanity's most important efforts to understand the Red Planet. This explorer, active on Mars since 2021, has already provided valuable discoveries about geological history and the possibility of ancient life. Its latest finding is a unique rock rich in iron and nickel, named Phipsaxla, which is likely a meteorite that arrived from elsewhere in space. This discovery not only holds scientific fascination but also offers new clues about the formation of the solar system and Mars's history. Perseverance has probably found its first Martian meteorite on the planet's surface, a rock with iron and nickel content that differs from other Martian samples. More than 5 years into its mission, the rover continues to roam the Martian terrain, stopping to examine every rock it encounters. One of its newest discoveries is a stone that looks strikingly foreign in its environment, leading scientists to suspect it may not have originated on Mars. The unusual 80-centimeter rock was found in the Vernadon region of Jezero crater and named Phipsaxla. NASA has released 2 images of the rock, one close-up and one from a short distance. What sets Phipsaxla apart from other Martian rocks is its composition. It is rich in iron and nickel, suggesting it has not always been on Mars and is in fact a meteorite that struck the planet in the past. Iron-nickel meteorites, far rarer than their stony counterparts, usually form from the cores of large meteorites. They originated in the early days of the solar system, when heavy materials sank into the centers of molten bodies. NASA scientists first noticed Phipsaxla because of its distinctive shape. The rock appears larger and taller than its surroundings, with a strange, carved-like appearance. After spotting this intriguing target, Perseverance used its advanced Mastcam Z camera mounted on its mast to capture several images. The rover also employed its supercam lasers and spectrometers to analyze the rock's chemical composition, precisely measuring its iron and nickel content. Although Phipsaxla may be a visitor from space, its presence in Vernadon of Jezero crater is not entirely surprising. Iron-nickel meteorites have been found in other parts of Mars before, so it is curious that Perseverance had not encountered one until now. To confirm that Phipsaxla is truly a meteorite on Mars's surface, further analysis is required. But if proven, this would mark another significant achievement for Perseverance, offering more insights into Mars and its history. Using its specialized drill, Perseverance is the first rover to collect Martian rock samples. A small onboard laboratory allows researchers to examine these samples more closely and identify their origins. If NASA decides to return a piece of Phipsaxla to Earth, the samples could be stored for future transport. Unfortunately, Perseverance cannot send rocks back to Earth on its own and would need another spacecraft for that task. Since its landing in February 2021, Perseverance has achieved many milestones. It has explored ancient lakebeds, discovered fascinating rocks, and found evidence suggesting possible ancient life on Mars. The rover has also allowed us to observe Martian landscapes up close, including volcanoes, something even the most advanced Earth-based telescopes cannot do. Perseverance has even set the record for the longest road trip on another planet, with more achievements likely ahead. There is no set end date for NASA's rover mission, meaning this small, resilient explorer will probably continue finding new rocks to share with us. The discovery of Phipsaxla once again demonstrates that every stone and sample on Mars can hold a vast story of the cosmos. If this rock is indeed an iron-nickel meteorite, studying it could deepen our understanding of the early processes that shape planets and mineral resources in the solar system. With its ongoing mission, Perseverance remains humanity's eyes and hands on Mars, and each new discovery marks another step toward understanding the universe and our place within it.